Hello ladies and gentlemen, today we're going to be talking about finding trig functions of any angle. So first thing we're going to start off with is talking about how to find the value of trig functions given an ordered pair. So if I'm in the coordinate grid and I am given point P, we'll call it, and that point is xy, that point exists on a line that is my radius of a circle. Okay, so I can find the trig functions of that angle theta by using a right triangle that I form with the ordered pair. So let me draw another picture. So with that point and that radius, I can make a right triangle. So I can make a right triangle here. This value is x, and this value is y. So I can find the different trig ratios of that angle. So we're going to call that angle theta, okay? Or theta prime, whatever you want to call it. But using what's called a reference angle is how you find your trig functions and trig values, because your angle is like rotating you to a certain point, and no matter if you look up or down, you can still find the trig ratios of that. But you want to make a right triangle with it. So sine of theta in this case is going to be opposite over hypotenuse, which is y over r. Cosine of theta is going to be x over r, so adjacent over hypotenuse. And tangent of theta is going to be opposite over adjacent, which is y over x. And my reciprocal functions are just the flip of that. So cosecant of theta is going to be r over y. Secant of theta is going to be r over x. And cotangent of theta is going to be x over y. So let's look at a problem where you're going to use this setup in. So they're going to give you a point, let's say -2, -5. And they tell you that that is a point on the terminal side of angle theta. Find the values of the 6 trig functions. Okay, so first thing I'm going to do is graph that point. So -2, -5 is going to be somewhere down here. Okay, this is -2, -5. And I'm going to create a triangle with that. Okay, so I have side lengths of -2 and -5. And I'm going to use Pythagorean theorem to find my radius, just like we did on the last video at the beginning. When we're trying to find the missing side length of a triangle, we use Pythagorean theorem. So I'm going to do -2 squared plus -5 squared equals r squared. So I get 4 plus 25 equals r squared. So 29 equals r squared. So the square root of 29 is equal to r. So the square root of 29 is my radius. So now I can find all 6 of the trig functions of that angle. We're going to call it theta of this triangle. So remember, we're always using this central angle here when we're trying to find our trig functions of a specific angle. You always want to use that central angle. So sine is opposite over hypotenuse, so I get -5 over the square root of 29, which when we rationalize our denominator, we get -5 square root of 29 over 29. Cosine of theta is going to be adjacent over hypotenuse, which is -2 over the square root of 29, which when we rationalize our denominator is -2 square root of 29 over 29. And tangent of theta is opposite over adjacent, which is -5 over -2, which turns into +5 over 2, because a negative divided by a negative is a positive. So cosecant of theta is going to be the square root of 29 over -5. Secant of theta is going to be the square root of 29 over -2. And cotangent of theta is going to be +2 over 5. And those are 6 trig functions of that point on that terminal side of that angle. So the next thing we're going to talk about are reference angles. So reference angles are super important for understanding your unit circle and using your unit circle. Okay, so reference angles are super important, like I said. So a reference angle is the acute angle formed by the terminal side of theta and the x, or the horizontal axis. So if my angle is in this first quadrant, this is angle theta, then my reference angle, I'm going to write in red, is that same angle. Okay, so this is my reference angle, the red line. And I'm going to use a symbol for angle there, so reference angle. Okay, if I have an angle in the second quadrant, this is theta, my reference angle is from where my line is down to the x-axis. So we always want to go to the fastest way to get to the x-axis. That's going to be my reference angle. So this angle here is my reference angle. In the third quadrant, I'm going around this way for theta. From here to here is my reference angle. Okay, I'm not going to write reference angle in there because I don't want to get it all muddied up. And then lastly, in the fourth quadrant, if this is my angle, then this angle here is my reference angle. So if this is theta, then that red line is my reference angle. So the way we calculate our reference angles, for the first one, I'm going back to the first one here. For the first one, there's not any calculation to do because that angle should be an acute angle. So whatever the angle is, that's my reference angle. For the second one, to find my reference angle, we do 180 minus theta, or if you're in radians, you do pi minus theta. Next one, to find our reference angle, we do theta minus 180, or theta minus pi. And in our last one, we do 360 minus theta, or 2 pi minus theta, if we're in radians. So this is how we calculate reference angles. So let's actually look at some problems doing that. So theta is 315 degrees. I'm going to draw that. I'm a very visual person when it comes to trig, so let's draw that. So 315 degrees is greater than 180 and 270, but less than 360, so it's out here somewhere. Okay, so this is 315 degrees. And my reference angle is from that line up to my x-axis. So the way I'm going to calculate my reference angle is I'm going to do 360 minus 315, which is 45. So my reference angle is 45 degrees. So this angle here is 45 degrees. Next one, we have negative 195. So when we go negative, we go down from our positive x-axis. So that's going to be greater than 180, but less than 270. So it's somewhere around there. So this is going to be negative 195, that angle there. And my reference angle is from here to here. So I'm going to take 195 and subtract 180 from it. I don't really care about the signs on this because I'm just looking to see how many degrees difference there are between 180 and 195. The signs don't really matter. So 195 minus 180 is 15 degrees. So this angle here is 15 degrees, and that is my reference angle. So next one, we're going to get into radians. So we have theta equals 25 pi over 4. I have no idea what angle 25 pi over 4 is. So what I'm going to do is take 25 pi over 4, and I'm going to change it into degrees so I can make sense of it. Because I can't make sense of radians when it's not small enough radian. So to get rid of pi, we put pi in the bottom, and we do 180 over pi. So the pi's cancel out. 4 goes into 180. Why am I having a brain fart? 2 goes into 4 2 times. And 2 goes into 180 90 times. I know that. And then 2 goes into 2 1 time, and 2 goes into 90 45 times. So we're going to do 25 times 45, which is 1125. So that's my angle, is 1,125. That's a really big angle, and that makes no sense to me still. So what I'm going to do is I'm going to subtract 360 from it until it gets down to a number that I can understand. So 1125 minus 360 is 765. I still can't make sense of that, so I'm going to subtract 360 again, and I get 405. I'm going to subtract 360 again, and I get 45. So that makes a little bit more sense to me. So this angle, it goes around 3 times, so it goes 1, 2, 3 times plus 45 degrees. That's a big angle. So my reference angle, because it's in the first quadrant, is just 45 degrees. So my reference angle is 45 degrees because this angle lies in the first quadrant. So next one, we have 13 pi over 3. So I'm going to take 13 pi over 3 because I don't know what angle that is, and I'm going to change it to degrees. So I do 180 over pi because I'm trying to get rid of pi. 3 goes into 180 60 times, so I'm doing 13 times 60 is 780. Again, 780 makes no sense to me, so I'm going to subtract 360, and I get 420, and I'm going to subtract 360 again, and I get 60. So 60 is my reference angle, but I'm going to draw it in a picture. So we went around twice. Here's 1, 2 times plus 60 degrees. So my reference angle is 60 degrees. Or in our case, if we change 60 back, we probably should change these back to radians. Let me go back to the last problem. So if we take 45 degrees and change that back into radians, we want pi, so pi goes in the top. So 45 and 180 have 45 in common, I think, if I'm not mistaken. I'm doing this in my head right now, so I apologize. Well, let's start with smaller numbers. So 5 goes into 45 9 times. 5 goes into 180, 20, and 20, and 80. How many times 5 go into 80? 16. So I'm having a brain fart on this. This is great. This is going to be wonderful on YouTube. Let me grab my calculator. So 180 divided by 45 is 4. Okay? So 180 divided by 45. So 45 goes into 180 4 times. And 45 divided by 45 is 1. So we get pi over 4. Okay? So 45 is the same as pi over 4. Then to change 60 degrees into radians, we're going to do 60 times pi over 180. And 60 goes into 180 3 times. So we get pi over 3. Okay? So 60 degrees is the same as pi over 3. Those are conversions that you need to automatically know. I automatically knew it. It was just the simplifying stuff I was not doing in my head. It was not working with me today. So one thing I want you to notice, and one thing that is really great about radians, is when they give you an angle in radians, you already know something. So look at the answer we got in radians compared to our beginning angle for both of these problems. So the answer I got in radians compared to the answer, the original problem I had. So if you look at them, they both have the same denominator. So when I'm given something in radians, it automatically tells me what my reference angle is based on the denominator. So if my denominator is 4, like it was on number 3, I know that 45 degrees is my reference angle. What I have to do from there is figure out where that angle is located in order to find values of different trig functions, which we're going to talk about in a minute. And the same thing with number 4. I see that it's 13 pi over 3. Over 3 is what I'm focusing on. That means that 60 degrees is my reference angle. So the one thing I really like about radians is when they give you an angle in radians, I automatically know what my reference angle is. I don't have to do any thinking or any of this extra changing it into degrees math. The only reason I would have to change it into degrees is to know how many times I have to go around the circle in order to get to where my terminal side is. So all the loops I had to make on number 3 and number 4. So let's look at actually evaluating trig functions, any trig functions, using reference angles. Okay? So we're going to talk about using reference angles. Okay, so first one I'm going to do is sine of 240 degrees. So first thing I want to look at is where 240 is located. So it's greater than 180 but less than 270. So 240 is located in my third quadrant. Okay, so that means that when I set up my triangle, my signs are going to be a little different. So when I set up my triangle for 240, so I'm doing 240 minus 180 to find my reference angle. So 240 minus 180, if my math is correct, is 60, which it should be. So that 60 degrees is my reference angle. So using our special right triangles that we talked about in the last video, my side lengths are 1, 2, square root of 3. Now the only difference is because of where I'm located on the coordinate grid, some of these sides are going to have a negative length. Okay, so my 1 is going to be negative and my square root of 3 is going to be negative because of where my terminal side is located. Okay, because I have to go left and down to get to where my terminal side is. So now I can calculate sine of 240 based off of this picture. So sine is opposite over hypotenuse. So sine of 240 degrees is going to be equal to negative square root of 3 over 2. And that's it. So another tool I want to give you is something I call cast. So in your coordinate grid, we're going to go in like a upside down horseshoe, well, I guess a horseshoe shape or a frowny face shape. Okay, we're going to go in this from here to here. Okay, so cast is what I call it. So C-A-S-T. This tells me what's positive and what quadrant. And they're reciprocals. So I use cast because it's easy to remember. The order I go in makes a frowny face. So usually when you're in a cast, you have a frowny face. So there you go. Just a way to help you remember that. So cast, C stands for cosine, and the reciprocal, which is secant. All stands for all, so everything is positive in the first quadrant. S stands for sine, so sine is positive in that quadrant, and it's reciprocal, cosecant. And tangent is positive in that quadrant, or cotangent is also positive because it's just the flip of it. Okay, so when I calculate sine of 240, I figure out what my reference angle is, which is 60. I think about where it's located in my coordinate grid, and I know that sine is going to be negative because tangent is positive in that quadrant. Okay, so I write out my special right triangle. And I circle the angle I'm trying to find, which is 60, because that's my reference angle. And I do opposite over hypotenuse, which is square root of 3 over 2. So that is how I use cast, which I just showed you over here, and reference angles to calculate the value of any trig function. So let's look at another one. So tangent of negative 225. So I look at where negative 225 is located. It's going to be greater than 180, but less than 270. So it's over here in my S quadrant. So that means tangent is going to be negative. So I know my sine is going to be negative. So then I got to figure out what my reference angle is. So I do 225 minus 180. So I'm writing out my problem here, like I'm setting up for my answer here. So 225 minus 180 is 45. So I'm finding tangent of 45 in my special right triangle. So I draw my special right triangle. So this is a 45, 45, 90. And I have 1, 1, square root of 2. So tangent is opposite over hypotenuse, which is 1 over 1, which is just 1. So tangent of negative 225 is negative 1. And that is how I use cast and reference angles to find the value of any trig function. So next one, we have secant of 11 pi over 6. So I'm going to take 11 pi over 6 and change it into degrees so I know where it's located. I already know my reference angle is going to be 30 degrees because it's over 6. So the reference angle isn't the question. I know what triangle I'm using to calculate my trig function. It's where it's located on the coordinate grid. So I'm going to change it into degrees. So I do 180 over pi. I multiply by 180 over pi. Pi's cancel out. 6 goes into 180 30 times. And 11 times 30 is 330. So if you want to visualize it, 330 is somewhere between 270 and 360, which is in the C quadrant, which means that secant is the reciprocal of cosine, so it means it's going to be positive. So secant of 11 pi over 6 is going to be a positive number. So, being that it's over 6 means that it is 30 degrees is my reference angle. And secant is the reciprocal of cosine. And cosine is adjacent over hypotenuse. So I'm going to do hypotenuse, which is 2, over adjacent, which is the square root of 3. So that simplifies when I rationalize my denominator to 2 square root of 3 over 3. So secant of 11 pi over 6 is 2 square root of 3 over 3. And the last thing we're going to go over is evaluating trig functions given other information. So I'm just going to call this eval trig functions. So this is how your problem is going to be set up. So given sine of theta is equal to negative 4 over 7, and cosine of theta is greater than 0, find cosine of theta and tangent of theta. Okay, so first thing I want to set up is cast. Okay, I know that sine is negative, which means it can't be here and it can't be here, because that's where sine is positive. So I know we're either in this quadrant or this quadrant. And they tell me that cosine is greater than 0. Cosine being greater than 0 means I'm in this quadrant right here. So I'm going to draw my picture and my triangle of theta, okay? And my sine was negative 4 over 7. So that means that it was negative 4 over 7. So now what I'm going to do is use Pythagorean theorem to find the third side, so that way I can calculate cosine and tangent. So I'm going to do negative 4 squared plus b squared equals 7 squared. So I get 16 plus b squared equals 49. And when I subtract 16 from 49, I get 33, so b squared equals 33, which means that b is going to be equal to the square root of 33. So this side is the square root of 33. So finding cosine of theta, we're going to do adjacent over hypotenuse, so that's the square root of 33 over 7. And tangent of theta is opposite over adjacent, so negative 4 over the square root of 33. And when we rationalize our denominator, we get negative 4 square root of 33 over 33. If I could write, that would be great. So that is how we use reference angles and cast, as I call it, to calculate trig values of any trig function that you're given. That's it for the video for today. If you have any questions, please let me know, and I'd be happy to answer them. Thanks so much for watching, and have a great day. Bye-bye.